Let's now continue creating our fire. So maybe I've mentioned this before, but one of the most important things within your simulations will be your emission. So let's put a little bit more detail onto our emitter and then go back to our pop network. So first of all, I will increase a bit the number of points. I will move my top network down a little bit just to make some space. And now I will lay down a pop wrangle node. Actually, I will use a point VOP. So I'm using a point VOP because I want to add some noise into our points, and it's easier to handle the noise parameters through the point VOP. So let's select the node. Let's change the color and change the name. I will name this set kill color. And I will dive into the node. So I will generate a variation in color on the points and then use that color to delete some of the points. Now, it's not necessary to create a color. I just like to see the noise within the colored points. That way it's easier to know what the result will be. So let's lay down a turbulent noise node. And I will connect the position of the points to the position of the noise. And then I will connect directly the noise to the color of the points. I will change the noise type to original Perlin and probably increase the frequency overall. So one very important thing that I want to do is go into the geometry spreadsheet and take a look at the ranges that I'm getting from the color or from the turbulent noise. So notice how the minimum color values are more or less within -0.4 and the highest values are more or less within the 0.5 values. So what I'm going to do is to fit both ranges between 0 and 1 values. For that, I'm going to lay down a fit range. I'm going to change the source minimum value to -0.4 and the source maximum value to 0.5. So now if we take a look at the colors, we'll have the minimum value around 0, the maximum value around 1, and all the rest of the values will be in between. So let's go back to our scene view. And another very important thing I want to do is to promote a few of the turbulent parameters, mainly the frequency and the offset. This way, if I go back to my SOP context, I will have these two parameters available up here. Now let's try deleting the darkest values. So lay down a delete node. Change the type to points and make sure that operation is delete by expression. So remember we have values going from 0 to 1. So I will type under the expression at CD, which is my color attribute. I will type .x, which is the first component of the color, or the red component, and then type is less than 0.5, then delete that point. So now we have a very nice pattern. So this is much more organic than just the circle, and it will create a much nicer emission. So let's go back to our pop network. And also let's increase the number of particles that will be generated. So let me go back to the SOP context and let's turn back the substeps to 1, which is the default. Let's now take a look into a very important aspect of the particle simulation. So I will dive back into the DOP network and I will start adding forces to the simulation. So remember, we initially added some velocity attributes. What I'm going to do instead is I will change the y value to 0. So now they will just be emitting in place. And what I'm going to do instead is to add a force that will push the particles upward. And for that, we have a very powerful node called the pop force. So I will lay down a pop force node and connect it here on the main stream. And I will change the upward force, or the force in y, to 5 meters per second. And let's press play just to see what this is doing. Now you will notice that the particles are being pushed upward, probably quite fast, but this is a good starting point. Now you could also create gravity with this node. For example, if we added a minus 9.8 meters, this will emulate the force of gravity pulling the particles downward. So in this case, for fire, we won't need gravity, but it's something that you can consider using. Now, another very interesting feature of the force node is the noise. So let me turn down the force to, let's say, 2 meters. And this time I will add a noise amplitude of 1. And press play. So now notice how the position of the particles is being disturbed, or actually the velocity of these particles is being disturbed by the noise. And this is giving us a very nice effect. We could change, for example, the swirl size to 0.2 and make the noise pattern much smaller. So this is giving a much more breakup feeling. Or probably go the other way. We could increase to 2 meters and make the swirls much bigger. So this is looking very nice. Of course, probably for fire, we will need to tweak this a lot. But just consider that the pop force also includes these noise parameters. So let's turn back this to 0. For now, we will only use the upward force. So let's call the node rise force. And another feature that I usually add in most of my setups is drag. So we also have a pop drag. I will connect this into the stream. I will leave the air resistance to 1, which is the default. And now if we press play, you will notice that the velocity of the particles is being brought down by the drag force. So it's multiplying the velocity down as the particles advance in time. And this will usually create a more natural look. So everything from dust, fire, and even debris will have a certain amount of air resistance or friction. And this can be given with a pop drag.